We will try one more like that. I'm going to go through this one much more quickly since most of this is review. We're just piecing together things that you already know how to do. So on this next one, if we look here, it's going to be, that was better actually, x1, y1. We're going to put that into point slope, at least at the beginning. So in this case, that's going to mean y minus our y coordinate of 4. This lovely slope of negative 1/3, and then x minus our x coordinate of 3. And then we'll start the work of reorganizing this. We'll distribute our fraction. So negative 1/3 x, right? When we distribute that into the x, it's just negative 1/3 times x is negative 1/3 x. And then negative times a negative becomes a positive. 1/3 times 3 is just 1. Okay, so we're here now. Then we'll move our constants. All constants always are on the right side. So we'll move the 4 over. So now I've got y equals that negative 1/3 x and the y-intercept of 5. There's slope-intercept for just a moment. Hi. How are you doing? Good. Okay, we're going to standard now. And then we move the x forward. We're going to keep moving forward to standard, so we'll move the x to the left side, to the front of the equation. And so when we do that, we get a positive 1/3 x with our y, and then we just have 5 on the other side. Now, that's great, and that's in standard form, but it's not fully cleaned up because we could put this in proper by simply getting rid of this first fraction. That denominator is a 3, so I'll multiply through by a 3 all the way down. And so 3 times a third, once again, is just 1x. 3 times y is just 3y. And 3 times 5 is 15. And there you have it. There's our standard form. Okay, so that's just really, like I said, piecing together things that you already knew how to do, which is very helpful. We'll probably just do one like this here because it's you're starting to see a pattern, I hope. Now we're looking to see, well, what if they just give you 2 points, right? Well, we find the slope then, right? Just like we did the last couple of days, you'll always need the slope. It doesn't matter what form you're in, you will always need the slope of your line, no matter what. So you have a step-by-step guide again here in your notes. What you'll want to do when you're given 2 points, whether it's in a graph or not, is find the slope of the formula, then use that slope and that point to write point slope, just like we did a moment ago. See, the rest of this is review, and then just reorganize it and rewrite it. So the only extra step here is that you have to find the slope yourself. Other than that, it becomes just like these guys that we just did. Okay, so let's try B here. And again, we could use the slope formula since they gave us 2 points, or since they gave us a graph, we could actually just work on rise and run. So if I have a graph in front of me, I can see here that we're going by ones. So to get from one point to the other, I see that I have to go up 1, 2, 3. That's an increase of 3. And a run of 1, 2. So positive 2. So my rise is 3 and my run is 2. So this has a slope of 3 over 2, rise over run. Okay, you could have also used the slope formula that we've been using, the y2 minus y1, x2 minus x1. Okay, but once I have this, I now can just use that slope and either point, right? We've talked about this. I think I'm going to go for the 6, 1, but you could use either one. Any point on the line should work. And we should be able to drop those into point slope since that's what we began with, right? Find the slope of the line, check. Use the slope and a point to write the equation in point slope. That's what we're about to do. So we'll do y minus our y coordinate equals this lovely slope right here, parentheses x minus our x coordinate. So now we have written point slope. So the last step is to just reorganize it so that it's in standard like we did just a few moments ago. We'll distribute the slope first. So 2/3 x times 2/3 times x is 3 over 2 times x is 3 over 2x. 3 over 2 times a negative 6 is going to stay negative, and then this is 18 over 2, which is 9, or you could also do 6 divided by 2 is 3 times 3, or you could throw it in your calculator. However you do it, it's going to be a 9, okay? And then we'll move our constants. So we'll move the 1 so that these guys are together. So now we are here, and this comes out to a negative 8. And then we'll move our x term to the front. Okay, I'm going to use up a little bit of space here. So now we've got a negative 3 over 2x with our y, and just a negative 8 on the other side. And that is in standard form, but you've heard me say this quite a bit today. We are going to clean this up by getting rid of that negative and that denominator, and I can do that with a negative 2. So I want to make sure I just multiply everything by a negative 2 here. And that leaves us with the negatives cancel, the 2's cancel. I get 3x. Negative 2 times y is negative 2y. And negative 2 and negative 8 is positive 16. No common factors. We're good. This is the proper standard form for that linear equation. There you go. Okay, so that's all new. I mean, that's all, most of that is review except for the standard part. Let's talk about vertical and horizontal. So this is just a real quick review because sometimes we do have to write. These equations are the same whether you're looking at slope-intercept or standard. Y'all, this is the whole Hoivux that I showed y'all a few days ago. So remember this, the Hoivux. Horizontal lines, vertical lines. Okay, horizontal lines have a 0 slope and they're always going to be written as x equals just the number, okay, the x coordinate, and the vux, its vertical are undefined, and they're written always as x equals the x coordinate, okay? So if I want to write the equation for a horizontal or vertical line that passes through these points, this is actually quite easy. For the vertical line, okay, so for the vertical line, it would just, that a vertical would always be x equals. And since the x value is the same everywhere on a vertical, then whatever this coordinate is, that is your equation. So x equals negative 1. How easy is that? And then for the horizontal, okay, it's always y equals the y coordinate, and so because on a horizontal the y coordinate is the same everywhere, it's just y equals 6. And once you get the hang of that, you see it's pretty simple, right? If you try B here, if they want the vertical line, it would just be x equals the x coordinate, which is negative 5. And if you want the horizontal line, the